Welcome. We're going to go over Appendix A, which is hardware and software basics. And we're going to be discussing technical architectures. A technical architecture refers to the structured process of designing and building a software architecture with the focus on the interaction with software and hardware. A technical architecture is part of the software architecture, which focuses on how to deal with certain parts of software engineering. It allows us to build a better system by making sure we meet the system requirements and objectives. And it also, good architecture enables a flexible distribution of the system by allowing it and its constituent applications to be partitioned among different processors, helps reduce the cost of maintenance and evolution to new systems based on changing environment requirements. And it also helps us increase reuse and integration with the legacy systems that we're confronted with when we're putting in a new system. So in Appendix A, we're going to go over three topics: hardware basics, computer categories, and software basics. And we'll describe the major categories of hardware and provide examples, identify the different computer categories and explain their potential business uses, and identify the two main types of software. So when categorizing computers by size for personal needs, the focus is typically on PDAs, tablets, notebook computers, and desktop computers. And there's several other variations, including smartphones or web-enabled cell phones, things that have text messaging and web browsing capabilities. The hardware is going to consist of six basic components, six basic hardware components. A central processing unit, and that's the actual hardware that interprets and executes the program, in other words, software instructions, and coordinates how the other hardware devices work together. Primary storage is the computer's main memory, and it consists of random access memory, RAM, cache memory, and read-only memory, ROM. All of those are directly accessible by the CPU. Secondary storage is equipment designed to store large volumes of data for long-term storage. And this would be things like disk drives and memory cards. Input devices are equipment used to capture information, things like a keyboard or a scanner. Output devices are equipment used to provide sound or print output, like monitors, printers, speakers. And then communication devices are used to send and receive location from one location to another. And that might be, for example, a modem. So memory's purpose is to store and retrieve data such as computer programs, documents, and input-output information. There's two types of memory. Main memory is costly but fast. It's used for frequently accessed data such as programs and input information during execution. It's volatile, so the data disappears when the power is turned off. Secondary storage is inexpensive but slow. Hard disks, thumb drives, cloud storage, and DVDs are examples. And it's permanent storage, so it's non-volatile. It does not disappear when you turn the machine off. Memory storage locations have addresses, and really memory is a collection of addressable locations. An address uniquely identifies a memory location, just like your home address. And data is usually bundled in units that are 8 to 64 bits in length. And a bit is just a 0 or a 1. Input-output devices include things like keyboards, a mouse, monitor, printers, and a network card. So a computer is an automated logic machine that quickly performs computations and makes logical decisions very fast. It stores, transforms, and retrieves data. A computer has hardware and software. Hardware, like we just mentioned, a keyboard, screen, mouse, memory, and CPUs. Software is a list of instructions written in a computer language such as Java or C or Python. And these instructions control the computer. The central processing unit manages operations of memory, arithmetic logic unit, I/O, and other components. It uses signals and informs input units when it's ready to take their input and place it in memory, and informs output to accept data from the memory unit to the output device. The arithmetic logic unit, ALU, performs calculations such as addition, subtraction, multiplication, and division. It performs logical operations of two types: relational comparisons, greater than or less than, and logical operations like and, or, and not. A bus connects the devices and sends signals to devices. So the CPU and memory are directly connected to the bus. The bus also connects I/O devices for CPU control signals and memory access. I/O devices are orders of magnitude slower than CPU and memory. Bus speeds are at The bus operates at CPU speeds, and I/O devices are not directly connected to the bus. You have an I/O controller card as an intermediary or interface between I/O devices and the bus in order to handle the mismatch in speed. So clock speed is the speed of the internal clock of a CPU, and that sets the pace at which operations proceed within the computer's internal processing circuitry. Clock speed is measured in megahertz and gigahertz. Faster clock speeds have noticeable gains in microprocessor computational tasks, such as calculating algorithms on an Excel spreadsheet. Word length is the number of bits, the zeros and ones, that can be processed by the CPU at any one time. Computers work in terms of bits and bytes, using electrical pulses that have two states, on and off. A binary digit, or bit, is the smallest unit of information that a computer can process. A bit can be either a 1 or a 0. A group of 8 bits represents a byte. Bus width is the size of the internal electrical pathway along which signals are sent from one part of the computer to another. A wider bus can move more data, and so it results in faster processing. Chip Line width is the distance between transistors on a chip. The shorter the chip line width, the faster the chip, because more transistors can be placed on a chip and the data and the instructions travel shorter distances during processing. So we have several different types of chips that can be put into your computer. And you can find this information out by doing a system info. So let's see how that works. So I'm going to share here. I'm going to go to my DOS prompt and I just type in system info and hit return. And it will gather a lot of the information regarding hardware, software, the operating system versions, and also a list of patches that have been applied to my machine, the start date when the machine was commissioned, and a host of other information. And you can see it's printing it out now. And these are all the patches. So let's take a look at some of this information. It's the name of my PC, the Windows version it has, the manufacturer, the processor, an AMD 64 at 17 megahertz, 1700 megahertz or 1.7 gigahertz. The directories you're going to find the operating system in, the boot device, physical memory, and the patches that have been installed over the years. Of course, this one was put into commission in 2012. So it's 8 years old. And so it has a lot of patches that were applied over that 8-year time period, network cards, and virtual machine information. So it gives a lot of information about your system. So I guess primary storage, again, we've covered that. It's volatile, very fast. And you use primary storage every time you fire up your PC. It loads the operating system, and parts of the operating system are in main memory. Every time you start a program such as PowerPoint, sections of code for PowerPoint will be put into main memory as well. Volatility refers to the RAM's complete loss of stored information if power is interrupted. A cache memory is a small unit of very fast memory that's used to store recently accessed or frequently accessed data, so that the CPU does not have to retrieve the data from slower memory circuits such as RAM. A flash memory is a special type of rewritable ROM, read-only memory, that is compact and portable. And memory cards, a high-capacity storage device that holds data. Typical data is captured images, music, or text files. Memory stick provides non-volatile memory for a range of portable devices, including computers, digital computers, MP3 players, and PDAs. They're extremely useful for storing and transferring files. So, if we have a computer that has 256 megabytes of RAM, that translates into the RAM being able to hold roughly 256 million characters of data and software instructions. Of course, nowadays, we've got RAM that is up in the gigabytes. Secondary storage, or disk drives, are getting up into the terabytes. So here are the binary terms that we use to designate the capacity of memory and also disk storage. We started with the PC back in 1981. We were talking about memory in terms of kilobytes and megabytes, like 10, 5, 10, and up to 20 megabytes for disk. And now we're using gigabytes for memory and terabytes for disks. And of course, we're heading for petabytes for disk drives. Tapes are another form of magnetic medium, and they're still widely used for archival purposes. Optical medium types include CD-ROM, and that's an optical drive designed to read data encoded on the CD-ROM and to transfer it into a computer. A CD-RW, and that's an optical drive that enables users to erase existing data and to write new data repeatedly to a CD read-write disk. DVDs, a CD-ROM format capable of storing up to a maximum of 17 gigabytes of data. DVD-ROM drive is a read-only drive designed to read the data encoded on a DVD, like a movie, for example, and transfer it to a computer. And then a DVD-RW, you can read and write both to a disk, optical disk. So, manual input devices, a joystick, a keyboard, a microphone, mouse, a pointing stick, a touch screen is an example, a touch pad for your mouse. You can also have automated input devices like barcode scanners, digital cameras, for banks, magnetic ink character readers, optical character recognition, point of sale terminals. So there's a number, RFID. For output devices, cathode ray tubes are not used much anymore. They were very, very common, even as little as 7 years ago. But they've rapidly been replaced with liquid crystal displays. They use less power. They originally were used in laptops, very expensive laptops, but they've become inexpensive enough that they've taken over the monitor market. A laser printer is a printer that forms images in the same way a photocopier works. And an inkjet printer is a printer that makes images by forcing ink droplets through nozzles. And a plotter is a printer that uses pens that you place in its arm, and it does high quality images, blueprints, and schematics. So the different types of communication devices include dial-up access, and that would be something like an on-demand modem or a modem that you have in your home to connect you to your cable provider or your telephone, regular POTS, plain old telephone line provider. Cables, a special cable modem and cable line are required. A DSL, digital subscriber line. This technology uses the unused digital portion of a regular copper telephone line to transmit and receive information. A special modem and adapter card are required. Wireless access is gained by connection to a high-speed cellular-like local multi-point communication network. Satellite, newer versions have two-way satellite access. So there's been significant breakthroughs in computing and how we organize computers. And there's three prominent ones. First is clustering, and this allows companies to chain together thousands of PCs to build mass market systems. Parallel processing provides the ability to run two or more tasks simultaneously, and the Mosaic browser, which developed into our standardized client that now a number of different vendors have, it's the internet browser. And of course, Microsoft Edge is an example, Netscape, Google Chrome, but they become a universal client. Here we see a wide variety of computer categories. A laptop is a fully functional computer designed to be carried around, and it runs on batteries. A tablet is a pen-based computer that provides screen capabilities of a PDA with the functional capabilities of a laptop or a desktop computer. A desktop available with a horizontal system box or a vertical system box. That's usually called a tower when it's placed vertically. A workstation is similar to a desktop, but it has more powerful mathematics and graphics processing capabilities. And of course, supercomputers, the fastest and most powerful and most expensive type of computers. And that's organizations like mainly government organizations are used in or use supercomputers in research and heavy number crunching. Now let's take a look at software. And the three types of software we might look at. Operating system software controls the application software and manages how the hardware devices work together. Utility software provides additional functionality to the operating system. And then application software is used for specific information processing needs. Things like your payroll system, your sales system, customer relationship management, office automation, those kind of software applications. So some of the types of utility software, crash proof, it helps save information if the computer crashes. Disk optimization, organizes information on a hard disk in the most efficient way. Encryption for security. File and data recovery to back up your system and restore it if something bad happens. Preventable security. And you can have this through programs like Window Washer, which erases file histories, browser cookies, cache contents, and other crumbs that applications and Windows leave on a hard drive. Here's some examples of application software. A browser enables the user to navigate the web, but it's also becoming a universal client. Most applications are written with a browser as the client, the thing that the user is going to interface with. Communications turns the computer into a terminal for transmitting and receiving data over the telephone system. Data management tools for data retrieval, modification, deletion, and insertion. Access is an example. MySQL is another. Desktop computing, that's going to be desktop publishing, Adobe FrameMaker, Adobe PageMaker. Email, groupware, presentation like PowerPoint, programming languages like Java, C++, Python, and so on. Okay, any questions?